Hello, and welcome to Calculus Lesson 111. Today we're going to talk about some indeterminate forms, but this time it's not going to be the indeterminate form 0 over 0 that you are familiar with. Instead, or we've talked about a couple of others, infinity over infinity or negative infinity over infinity. Those are the indeterminate forms we've covered so far. But what if it's not a fraction? What if it's an exponent? What if we have 0 to the 0 power, or 1 to the infinity power, or infinity to the 0? You know, it feels like this should be maybe 1, feels like this should be 1, feels like this should be 1, but it's not always the case. So let's go ahead and look at some examples here. We have the limit as x approaches 0 from the right of x to the x. So right now I have 0 to the 0. It isn't necessarily 1. We have to be able to prove that out. Just because it feels right doesn't mean that it's necessarily correct. And so the trick we're going to do here to get rid of the exponent is to actually take the ln. Why? Because I can bring the exponent down when I take ln, and it makes my life better. But the problem is I can't just say, oh, well, let's just do ln of x to the x, because that's changing the problem. So what I have to do is take e to the ln of x to the x. E to the ln undoes each other, so I can get away with that, and then I can solve this problem. So let's simplify this a little bit further. Of e to the, now if I bring down the x, I get x ln of x. Now I have 0 times negative infinity. Still a little iffy. All right, so what am I going to do now? Well, we can simplify this a little bit by bringing out the e. Since e to the really doesn't matter, e doesn't depend on x at all, so I can pull that out and then evaluate the limit inside here. Now, x ln of x is a little funky. I can rewrite this in a way that gets me infinity over infinity, and I can apply L'Hopital, which is, if I'm not mistaken, yep, ln of x over 1 over x. Remember, this is all the exponent of e because I had to take e to the ln to make sure that I didn't change the problem. This is now negative infinity over infinity. That is indeterminate, and so I can do L'Hopital. And then I get e to the limit as x approaches 0 from the right of, well, ln of x, the derivative of that is 1 over x. The derivative of 1 over x is negative 1 over x squared. So if I evaluate those, I get negative x. What is that going to be? Well, it's going to be simply 0. What's e to the 0? 1. So in this case, it does turn out that the indeterminate form is 1. Let's move on to the next one. We have the limit as x approaches infinity of 1 plus 2 over x to the x. Now, what's my issue here? Well, we have 1 plus something really small to a really high power. If I just add 1 to a really high power, I would kind of feel more comfortable just saying it's 1 and moving on. But I have 1 plus something to a really high power. So what do? Well, I'm going to start off again by trying to get rid of that x. So I'm going to take e to the ln like that. Okay? That's going to allow me to break this down a little bit. It's kind of like in our lives when you have to take drastic measures to deal with things going on, right? And you're like, ah! And you're like, all right, cool. I know what I need to do. I need to address this biblically. I need to go to God's word and figure out what to do. Here, you just have to know this trick, okay? You have to know that you can manipulate powers using ln's. And so if you take the ln of this, it's going to help you out. So we have the limit as x approaches infinity of x ln of 1 plus 2 over x. Now from here, again, we're going to do the same trick here where we make it something that we can do L'Hopital with by doing ln of 1 plus 2 over x over 1 over x. 1 over x is 0 when you plug in infinity, and ln of 1, when I plug in infinity, this term goes away. That's also 0, so I have 0 over 0. When I take the derivative of that, I get something really, really, really gross. That's disgusting. All right, so I get e to the limit as x approaches infinity of the derivative of this, which is 1 over 1 plus 2 over x times the derivative of the inside, which is negative 2 over x squared times 2. So that would be negative 4. Ooh, am I doing this right? Nope, just negative 2 over x squared. Then we're going to divide it by the derivative of the bottom, which is negative 1 over x squared. So these x squareds cancel, these minus signs cancel. Now I'm left with this, which isn't bad. 2 over 1 plus 2 over x, that looks like 2. So the answer is e squared. Okay, so even though we felt like that should be 1, actually was not so. Let's try another one. We're going to take the limit as x approaches infinity of x to the 1 over x. Again, we need to use our ln trick. It's the one thing we know that will work here. So I'm going to do e to the limit as x approaches infinity. A lot of students forget the e every time, and then at the end, they just say the answer is 2 instead of e squared. I'll take the ln already, so I get 1 over x, ln of x. This is infinity over infinity, so I can do L'Hopital immediately. So I have e to the limit as x approaches infinity of derivative of the top is 1 over x, derivative of the bottom is 1. So I have 0 up here, so that looks like 1. And that, my friends, is Calculus Lesson 111.